Hello, Mr. Richards here, and today's lesson is on the distributive property. You'll learn how to use the distributive property to write equivalent numerical and algebraic expressions. Now, what is the distributive property? Well, basically, if I have b plus c, and I want to multiply b plus c by a, one thing I can do is say, all right, I'm going to take a, multiply it by b, and take my a and multiply it by c, so that I get a times b plus a times c. If I had numbers with that, and say I had 2 times, I don't know, 3 plus 4, now I know you can go 3 plus 4 is 7 times 2 is 14. I know you're smart enough to do that. But if we were to use the distributive property, I could say that's going to be 2 times 3 plus 2 times 4. And of course 2 times 3 is 6, 2 times 4 is 8, and 6 plus 8 is also 14. Now, does this work with multiplication and subtraction? You bet. We could have a times b minus c as well. And when we distribute that, the only difference is you would still get a times b, but the difference here is you're going to subtract a times c. The key is that sign there, the b minus c. When it was the b plus c, we had the addition. When it was b minus c, we're then subtracting. And likewise, I can choose some different numbers here. 2 times 5 minus 3. And that's going to equal, once I distribute, 2 times 5 minus 2 times 3. And of course, 2 times 5 is 10, 2 times 3 is 6, and 10 minus 6 is 4. Just like if you're to do 5 minus 3 is 2, times 2 is also 4. But obviously we look at the numbers just to prove that this works and to see how it works in order when we get to these algebraic expressions without being able to combine like terms, how it works that way as well. Now, use the distributive property to write each expression as an equivalent numerical expression, then evaluate the expression. So a couple different steps here. First, we're going to take our 4 and multiply it by the 5, and then our 4 times the 8. Now it does say to write each expression as a numerical or equivalent numerical expression before we evaluate, before we solve. So we have to take and write 4 times 5. We have a plus, so plus 4 times 8. You have to write the expression out. Well, now in order to solve this, 4 times 5 is 20, plus 4 times 8 is 32, and 20 plus 32 simplifies into 52. Now, what about 6 minus 9 times 2? That doesn't look like any of the examples we've just done. Well, what if we rewrote this as 2 times 6 minus 9? What if we move this 2 to the other side? You're allowed to do that if it makes it easier for you to solve. So we're going to take our 2 times the 6 and then subtract the 2 times the 9. So we'll have 2 times our 6, subtracting then our 2 times the 9. 2 times 6 is 12, minus 2 times 9 is 18, and 12 minus 18 is negative 6. A community center is offering a canoeing day trip. The canoeing fee is $99 per person to find the total cost for a family of 4. It says you can use the distributive property and mental math, in quotes there, to find the total cost of the trip. Well, essentially, we have 4 people times $99 each. I can't do that in my head. I mean, maybe I can stretch it out, but probably would make a mistake in doing so. One thing you could do here, we can take our $99 here and break it into 2 different numbers. What if we take this $99 and write that as 100 minus 1? 100 minus 1 is 99. Then I can use the distributive property here in order to solve this, because this would be 4 times 100 minus 4 times 1, and of course 4 times 100 is 400, 4 times 1 is 4, 400 minus 4 is $396. Of course, I have mental math and quotes there as we showed a bunch of work to do this mental math, but this is the type of way you could break this down to eventually be able to do this mentally, taking our $99 and breaking it into 100 minus 1. Now, some of you may go, well, I can take this 99 and I can break that into 90 plus 9. Yeah, you could. You'd still have to do 4 times 90 is 360 plus 4 times 9 is 36 and get your 396 that way. I mean, you could, but I still think it's easier to do 100 minus 1 when comparing that to 90 plus 9 if your goal is ultimately to be able to do this in your head. Our third example now, use the distributive property to write each expression as an equivalent algebraic expression. Notice the first example were numerical expressions with just numbers. Now we have algebraic expressions, and we're going to solve these pretty much the same. We can take our 2 and distribute it to our x and our 4. So this is going to be 2 times x plus 2 times 4. 2 times x is 2x, plus 2 times 4 is 8. Our x, or 2x and our 8 are not like terms. You cannot add a 2x with an 8, so you just leave it there, 2x plus 8. Our next example, y plus 3 times 6. Now, again, if you're more comfortable with this number, the 6 being on the left side of the parentheses, go ahead and just rewrite it if you're more comfortable doing it that way. So we have our 6 times our y plus our 6 times the 3. 6 times y is, well, 6y. 6 times 3 is 18, and that's our answer, 6y plus 18. It's not going to add in to be 24y, just 6y plus 18. And our last set of examples, use the distributive property to write each expression as an equivalent algebraic expression again. But we're throwing in some negatives here, just to make sure we understand what we're doing. We're going to distribute this 4 to the x minus 4 times 2. Notice we have the subtraction. So we have 4x minus 4 times 2 is 8, so 4x minus 8. Now, when we have the negative in front and the negative inside, you have a couple different options here. What I would suggest doing is rewriting this. Since you notice we're multiplying a negative and then there's going to be a negative here, one way of doing this is to say, okay, this is going to be negative 2 times n plus a negative 3. Rewriting the subtraction, keep change opposite. Because when you do it that way, and you distribute this now, we have negative 2 times n, still the plus, negative 2 times negative 3. So that way, negative 2 times n is negative 2n, and then negative 2 times negative 3 is simply a positive 6, so we have plus 6. Just recognize that I have a negative times the negative is a positive 6. And that's it. Good luck.